All right, this is problem 23. We get a break a little bit from the words here and are back just to a function. This is y equals f of x, either one, equals 10 over 1 plus x squared. They tell us dx dt is 3 centimeters per second, and they want dy dt. And there's three different parts, but don't worry, once we've done most of the work, the part B and part C will follow very quickly. So, they're like us to find dy dt when x equals -2, x equals 0, and y equals 20. All right, let's begin. So part A will do, but like I say, part B and C will follow very quickly after that. So we've got y equals 10 over 1 plus x squared. The question is, they give us a dx dt, find dy dt, so let's take the derivative. Oh, I don't know, let's take it with respect to time. This is about the 10th problem in the homework, so you probably knew that already. So let's take the derivative with respect to time. On the left side, I've got dy dt. On the right side, I've got a bit of a quotient rule, so I've got ho d high, but d high is 0, guys, minus high d ho all over ho squared. Simplify, oops, and I just forgot something, didn't I? So I've got ho d high minus high d ho. The derivative of x squared is 2x, but guys, this derivative is with respect to time. So I needed the dx dt right there. That was a horrible mistake. So let's see. Ho d high, the root of 10 is 0. High d ho x squared is 2x. The chain rule gives me that dx dt. And the bottom, it's ho squared. There's no derivative there. That looks a little bit better. Simplify the top. It looks like a negative 20x dx dt. And I've got a 1 plus x squared, the quantity squared, on the bottom. Okay, I've done most of my work. I notice in the problem, look, they told me dx dt is 3. I've now taken the derivative, I can sub that in. And so I get dy dt, kind of my general equation here. Dy dt equals, when I sub in 3 for dx dt, negative 60x over 1 plus x squared squared. All right, we've done most of the work. Let's do part A, dy dt. Let's figure that out when x is how much? -2. Put a -2. I've got a -2 squared. That looks like a 120 on the top. And the bottom, -2. Oops, got out of the square there. -2 squared is 4, plus 1 is 5. 5 squared is 25. And if I divide that, it looks like a 4.8. What were our units? It's y, it's a length. And that looks like centimeters per second. All right, let's try a B and a C on this. Same equation, just sub in a different value. dy dt equals -60. What is x this time? Oh shoot, I forgot. Let's see. X is 0. Oh, very nice. Put in a 0. Not too worried about the bottom being undefined because I got that 1 plus. And this comes out to be 0 centimeters per second. Maybe I can keep track of my answers here. There was part A. That was a positive. There's part B. That was a 0. And now let's get part C. dy dt. We've got our -60. What is x this time? 20. So I'll put in the 20. On the bottom, I've got 1 plus 20 squared squared. This will be a little bit of a mess. We'll get our calculator here for a nicer answer. Well, not a nicer answer, but an approximation at least. Looks like a -1200 on top. And it looks like a 20 squared is 400 plus 1, a 401 squared on the bottom. And I see a negative. Was that first problem -2 for x? Yeah, x was -2. Okay. And I've got -1200 over 401 squared. Let's get our answer there. That was a, gotta scoot that up just a little bit. All right, a -1200. And I'll divide that by 401 squared. All right, what do we get for this? A -0.007. And again, the AP wants 3 decimals of accuracy. So if I was writing that, I could write it negative 1200 over 401 squared, or I could write it as negative 0.007. You can always leave more decimals, 46. And I get our units for centimeters per second. And I'll circle that just like the other two. And that completes our problem.